Hi, the research of our group is about monitoring people and vehicles with radar. Radar sensors are increasingly being used to assist in the process of sensing the surroundings of vehicles. In challenging conditions such as night sunlight, snow, rain, or fog, the use of cameras is limited, adding the growing concern for privacy and data protection issues, which makes the use of these technologies problematic. A radar sends a signal via the transmitting antenna, which, in the event of meeting an object, reflects off the object's body and will be received by the radar via its receiving antenna. When the wavelength of electromagnetic waves transmitted by the radar is properly selected, it provides robustness in the bad weather conditions. Within the frequency-modulated continuous wave radars, there is the microdoppler radar based on the Doppler effect, the most suitable for detecting pedestrians, vehicles, or cyclists. This type of radar transmits a continuous wave while continuously varying the frequency of the transmitting signal at a known rate over a fixed period of time. Therefore, with a microdoppler radar, it is possible to extract the range, size, and azimuth of objects, and also with continuous measurements, it is possible to estimate the speed of these objects. That is, with the travel time of the signal to the vehicle, the distance and azimuth is obtained. With the frequency change, the speed of vehicles is calculated, and with the strength of the received signal, the size of the reflecting object is obtained. With these measurements, it is possible to identify the object present in the scene.
With information of the received signal from the object in the time domain, it is possible to apply transformations to that signal to obtain meaningful information about the characteristics of the object, such as fast-Fourier transform. This one can separate all the frequency compounds and give the frequency response of the received signal, obtaining the spectrum of the signal as represented in Figure 5. Thus, it's possible to conclude that there is one small object at a short distance, a pedestrian for example, and two larger objects at a greater distance. As said before, in addition to being able to estimate the range and size of vehicles, with a Doppler frequency it is possible to calculate the speed of the object. Adding the speed to the previous graph, we have the result in the third dimension shown in the figure. The x-axis shows the speed, the y-axis shows the distance, range, between the radar and the object, and the colors indicate the strength of the received signal. The third parameter we can measure is the angle of the reflected signal. When measuring a single reflected signal with different antennas, the frequency change of the detection is equivalent to the angle, that is, azimuth of the object. The figure 7 is a representation of radar data using the distance between the radar and the reflecting objects, as well as the azimuth. We can see two objects just in front of the radar, but also an object with a significant reflection on the right side. Thank you for your attention. We hope you enjoy it and have the rest of a good day.